Hey mathletes, so today we are going to solve algebraically and graphically equations containing radical expressions. This is the day you all have been waiting for. Alright, so the basic premise to solving an equation that has a radical or a rational exponent, because we're going to talk about both those today, are to eliminate. This is our goal. Our goal is to eliminate the radical or the rational exponent. And there are generally three steps to solving these. The first step is to isolate the radical or rational exponent term. If this is possible. If there are two, then you want to make sure there's one on each side, and we'll take a look at some of those in a bit. Your second step is that you would raise both sides of the equation to the reciprocal power. And then the last step is to solve and check your solution. And I know I say you need to check your solutions a lot, but when we are solving radical or rational exponent equations, we can run into extraneous solutions. So you want to be careful with those. So you want to check for extraneous solutions. And my question to you, and this is something we'll discuss in class, is why would we have extraneous solutions when we're solving radical or rational exponent equations? So hopefully we can have this discussion next class. All right, so let's look at some examples of types of equations you may see out in the wild or on a worksheet or a test. All right, so here's what we have to do. So our first step is that we have to isolate our radical expression. So this is our radical expression right here, and we have this minus 5, so we need to get rid of that. So I'm going to add 5 to both sides. And now I'm going to move it over more center. We have the cube root of 8x plus 3 is equal to, now that is equal to 3. So now we need to raise it to the reciprocal power. Well, we know that the cube root is the same as the, that's the 1/3 power. And so the reciprocal of that is raising it to the third power, the 3/1. So I'm raising both sides to the 3/1 power. And what that's going to do is that these two are going to cancel out because 1/3 times 3 is 1, so we're just left with 8x plus 3 to the first power. So basically they cancel each other out because they're inverse operations. And 3 to the third is 27. And now I'm back to a linear equation, and I can just solve this. So if I subtract 3, I have 8x is equal to 24, and then x is equal to 3. If I want to do a check to see if I'm correct, I just need to plug in my 3 back into my original equation. So if I do that, I have the cube root of 8 times 3 plus 3 minus 5, and let's see what this is. Well, this is 24, plus 3 is 27, so it's the cube root of 27 minus 5. Cube root of 27 is 3 minus 5 is -2. And you could also just plug this into the calculator and check it that way. And so here we have this solution. It works, so we are good to go. Moving on. So now we have the cube root written as a rational exponent, because we know that 1/3 power is the same thing as the cube root. So again, our goal is to isolate our piece that has our rational exponent. So our first step is I'm going to add 8 to both sides, and then I have 2, and then 2x plus 3, 1/3, and that is equal to 6. Now I need to do one of two things. I can either raise the entire thing to the 3rd power right now, or you can divide by 2, which is what I'm going to do right here. And now I have 2x plus 3 to the 1/3 is equal to 3. So now I'm going to do the reciprocal power of this. So I'm going to raise this to the 3rd power, and then 1/3 times 3, those turn into 1, so I'm left with 2x plus 3, and then 3 to the 3rd again. I'm so original, and we have 27. All right, so 2x is equal to 24, and then we divide by 2, and x is equal to 12, so at least we have a different answer this time. And again, we can plug in and check, see what our answer works out. We have 2x plus 3, but x was equal to 12, so I'm going to plug that in. Plus 3, and that's the 1/3 power, and then we're subtracting 8. Well, this is 24, plus 3 is 27, so we have 2 times 27 to the 1/3 minus 8. Well, the 3rd root of 27 is 3, so we have 2 times 3 minus 8, so 6 minus 8, which is -2. So that worked. Super duper. Alright, so now we have something raised to the 7/3 power, so it's not to the 1/3 power. So we have to do things a little bit differently. So again, we want to isolate our term that has our rational exponent. Well, that's this one right here. So we need to get rid of this plus 22. So I'm going to subtract 22, and now I have 3x plus 5 to the 7/3 is equal to 128. So now I'm going to raise it to the reciprocal power. So the reciprocal of 7/3 is 3/7. So I'm going to raise both sides to the 3/7 power. So now on the left side of my equation, our powers 7/3 times 3/7, that just becomes 1. So I'm just left with 3x plus 5, which is nifty. And then on the other side, I have the 7th root. I'm going to rewrite this of 128 cubed. Because remember, our numerator is our power and our denominator is our root. So that's the 7th root of 128 cubed. So we can write it like that. So now I need to figure out, well, what's the 7th root of 128? So we need to write down our factor tree if we don't know what this is offhand. And so I'm going to take 128. I'm going to break it down to 64, 2, 32, 2, 16. I can keep going. 2, 8, 2, 4, 2, 2. There's a whole bunch of 2's. There's 1, 2, 3, 4, 5, 6, 7 2's. So I could rewrite this side. This is the 7th root of 2 to the 7th cubed. Well, this works out very nicely. Well, if this is the 7th root of 2 to the 7th, well, this whole part right here just becomes 2. So this is 2 cubed, which is, well, what's that? Well, that's 8. So 128 to the 3/7 is just 8, and that is equal to 3x plus 5. Now we're down to a linear. I subtract 5 from both sides, and I have 3x is equal to 3, and then x is equal to 1 when I divide. So that is our answer for that particular one. And so I can check this on the side if I want. I'll do that over here in this checking bubble cloud of mystery. So I have 3 times 1 plus 5 to the 7/3. Well, this is 8 to the 7/3. Plus 22. Plus 22. All right. Well, we know that the third root of 8 is 2. So the third root of 8 is 2. So this just turns into 2 to the 7th power plus 122, or excuse me, plus 22. And then we know 2 to the 7th from our previous discovery over there is equal to 128 plus 22, 150. Checks out. All right, so this one's different. Here we have two radicals. So when I said that we needed to isolate the radical when we could, this is a time when we can't. But this is nice because we have a radical on both sides, and it's the same index. They're both they are both the third root. So we could raise both sides to the reciprocal, to the third, and on the left side, well, that's just going to be 2x plus 4. And on the right side, here's where I've seen folks in the past make mistakes. They'll write 2 and then and then 3 minus x. But you need to think when you're raising this to the third power, you're raising both components because these are being multiplied. So you need to raise the 2 to the third also. So this should actually be 2 to the third, which is 8. So this needs to be an 8. So that's a common mistake I've seen people make when they are raising parts of their equation to a power, and they don't do both pieces. So now we just need to distribute this. So this is 24 minus 8x is equal to 2x plus 4. I'm going to add the 8x over here and subtract the 4. So I do that and I have this is 10x is equal to 20, and it's equal to 2. So x is 2, and we can plug it back in and check if we wish. We can do that. So we'll do that over here. So you can see I checked both sides because both sides have an x. The left side goes to 2. Right side goes to 2. It all works out since both sides are equal. We know that our solution of 2 was correct. Right, let's look at this one. This looks similar to our other ones. Well, this is a square root problem. So I'm going to raise both sides to the second power and see what we got. Well, on the right side, we know we're going to end up with 7x plus 15. And now what about the left side? Well, this is a binomial square. This is x plus 1 times x plus 1, which we know is x squared plus x plus x plus 1. So that's x squared plus 2x plus 1 when I distribute that out. So I have x squared plus 2x plus 1. So this is why we spend that much time on quadratics, because it pops up in a lot of different places. So we know we have a quadratic now because it's squared, so I need to solve this quadratic equation. And how do I do that? Well, we solve quadratics by moving everything to one side and setting it equal to 0. So if I do that, if I subtract, I have x squared minus 5x minus 14 is equal to 0. So this is a nice quadratic in that it factors. We have factors of negative 14. Factors of negative 14 that add up to negative 5 are negative 7 and a positive 2. So this is x minus 7 and x plus 2 equals 0. And then I have x is equal to 7 and negative 2 from this using the zero product property. So now I want to plug in my answers, okay, because I need to plug them in to see if they are correct. Then I have two answers here. Well, let's see if they both work. So if I plug in the 7, we'll do that. Plug in the 7. I'd have 7 plus 1, and that is, want to see if that's equal to the square root of 7 times 7 plus 15. Well, this side is 8. And this is the square root of 49 plus 15, which is the square root of 64, which is 8. So it checks out. Those work. Okay. So that checks out. So we got 8 on both sides, so it works. So 7 works. So now let's plug in -2. Well, if I plug in -2, I would have -2 plus 1, and then want to see if that's equal to the square root of 7 times -2 plus 15. Well, this side, -2 plus 1 is -1, and hold on a minute. This is a square root. This is -1. I can't get a -1 when I'm taking a square root. So I know that this one won't work. And we can keep going on this if you want. So this would be the square root of -14 plus 15. And this is the square root of 1, which is 1, which is not -1. So these are not equal. So -2 is a trickster. That is a extraneous solution. So this doesn't work. Does not work. Bad -2. Bad. All right, so 7, you are our friend. -2, you're not. All right, and so you saw in the objective how we're going to solve them algebraically and graphically. Well, to solve them graphically, we either need to use a calculator or it needs to be in a transformational form of a square root or a cube root, which we can do. So let's solve this both ways. So you can see the approach and see why we might like one way better than the other. So here's what we're going to do. First step to solve this algebraically. I don't want to square both sides like this. This is not going to be helpful. So what I'm going to do is I'm going to move this radical to the other side. And so now I have square root of x minus 3 is equal to 3 minus the square root of x. So now I need to get rid of at least this radical first, and let's try to do that. So we would square this. If I do that, I have to square this. Well, the left side is nice. It just goes to x minus 3. The right side, we have a binomial here now of 3 minus the root x squared. So let's write out what's that going to look like, because this is a bit different from things that we've seen. So it looks like this, and I'll multiply this out for us. So we have 3 times 3 is 9. 3 times a negative root x is a minus 3 root x. And then a negative root x times 3 is minus another negative 3 root x. And then a negative root x times a negative root x is going to be a positive x. Okay? Think about that. A square root of x times a square root of x is just going to give us our x when we do that. So I'm going to simplify this. So I have 9 minus 6 root x plus x is equal to x minus 3 over here. Okay. So now I'm going to condense my terms. I'm going to subtract 9 from this side and then subtract an x, because I have an x on this side. And when I do that, subtract 9 and then subtract the x, on this side I get negative 12 because the x's cancel, and on this side I get negative 6 root x. Now I divide by negative 6, I'm going to get 2 is equal to the square root of x. And so now I need to square it again to get rid of that radical. So I square it again, and I get 4 is equal to x. Okay? So that's a couple steps. It's not too bad. It's things that we all know how to do, or can do, have the ability to. But let's see if we can solve this a different way. This is certainly not in a transformational form. This is just a line. But here's something you can do. See what our first step is that we had when we were solving algebraically. I'm going to do that over here, but I'm going to rewrite it a little bit. I have the square root of x minus 3 on one side. That we can graph. And then equals, I'm going to write it as the negative square root of x plus 3. Okay, so I've moved the square root of x over, but I've put it in front. Now it's in the transformational form, and I can graph these two pieces and see where they intersect. So I'm going to graph these two functions. F of x is equal to the square root of x minus 3. And I'm going to graph f of, we won't call it f of x because we already have one of those. We'll call it g of x. I'm going to graph g of x is equal to negative square root of x plus 3. So let's graph f of x in red. Okay, so it's the square root of x minus 3. So that's the square root function that's been moved to the right 3 units. So it's just moved to the right 3 units, so I know it's our 0, 0 goes to 3, 0, and then over 1, up 1, and then over 4, up 2. So this is our f of x. Now let's graph g of x in purple. So we're going to graph g of x in purple right here. Okay, so what is this? Well, this is our square root function that has a dilation of -1 and has been moved up 3. So our 0, 0 goes up 3 right here. Okay, because there's no h value, just a k value right there. Up 3, and then our dilation is -1. So instead of going to the right 1 and up 1, I'm going to the right 1 and down 1. Instead of going to the right 4 and up 2, I'm going to the right 4 and down 2 right here and graph my function. And you can see we have an intersection, a clean one right here. And where do they intersect? Well, they intersect right here, and that is when x is equal to 4. So we solved it graphically and algebraically. Both solutions correspond, they're the same. I prefer the graphical approach for this particular one. I think it's a little bit cleaner and a little bit more elegant, but you could do it either way. So there's that. So folks, that's it for today. That's solving radical and rational exponent equations. I hope you found this useful. I will see you guys in class. Have a great day, morning, or evening.